Scholars begin from many different starting points in their examination of what it means to be human. They may see us primarily as social beings, as rational ones. Others may begin from the idea that we're embedded within history or within our languages. Professor Dale Jamieson, whom I'm delighted to welcome to the Penn Humanities Forum, is a leading figure among a growing number of philosophers and ethicists who see us primarily as living organisms. Professor Jamieson joins us from New York University, where he is director and professor of environmental studies, professor of philosophy, and affiliated professor of law. He has authored or edited some 8 books in which he presses forward a deep understanding of what such a creaturely perspective can teach us. His volume on Singer and His Critics, published in 2000, took away the Choice Magazine Award for Outstanding Academic Title of 1999. He has written over 100 essays on humans, animals, the environment, and how we might all live together. The essays are particularly a joy to read. They're written always with a crystalline intensity and a passionate fairness. In reading over these works, one is first impressed by the extraordinary reasonableness of the main idea. There's no denying that we are organisms that, like all other organisms, metabolize our way through birth, reproduction, and death. This perspective, of course, has some precursors in history, in Aristotle, in half of St. Augustine, in the Romantics, and Darwinists of several stripes. But one aspect in particular is unprecedented in the kind of thinking that Professor Jamieson does, and it points up the unique power of his thought. He resolutely resists the very tempting idea that humans are somehow singular or exceptional, at some level irreducibly incompatible with everything else. Instead of a mystified sense of our own grandeur, we find ourselves always on a gradient with all other living things. In making our ethical calculations, we operate on a deeply reciprocal relationship with the world, not unlike the reciprocity that underlies the metabolizing organism, in fact. And we do not operate as autonomous nodes of reason, judging from some abstract plane. Such a perspective makes salient a whole host of issues that go unnoticed if we seek our humanity primarily in our social, rational, historical, or linguistic selves. For example, our allegiance to our own species, once thought to be the very highest marker of a humane frame of mind, now appears somewhat chauvinistic. Imagine a world, for example, where bees were the dominant species. Shouldn't we think that they ought to be nice to us too? What do we mean by natural resources? The phrase itself claims that the world is somehow essentially instrumental to our well-being. Aside from some kind of theological claim, it's very difficult to imagine where the authority for such a view might come. As we will have the pleasure of understanding in this evening's talk, we might also wonder what it is, what power our role has had in changing the atmosphere in which all of living things live and breathe. He's held fellowships from Princeton, the Pew Foundation, and the North American Society for Social Philosophy. He is also a past president of the Institute for Society and Environmental Ethics. And we look very much forward to his talk today on the moral and political challenges of climate change. Professor Dale Jamieson.
Well, I'd like to thank Peter for that generous introduction. I'd like to thank the Penn Humanities Forum, particularly Wendy Steiner, for inviting me. And I'd like to thank all of you for coming out tonight. Now, I have to find the remote. Yes. Okay, thank you very much. So we'll see if we can get things going here. Not a good start. Yes, okay. So, my title tonight is Global Warming, but it has a subtitle. If we can change you can believe in, and should try to do something about. So tonight I'm going to begin by giving you a brief tour of the history of thinking about climate change. You'll discover that it wasn't an issue that suddenly appeared on the horizon when Al Gore won the Nobel Peace Prize in 2007, but indeed has a long and honorable history of scientific investigation. We'll move on from an overview of the history of the issue and of the science to talking about the moral and political questions that climate change raises. And I will say in this part of the talk, I hope, some provocative things. We will then move on to what I hope is really the message of this talk, which is that climate change raises issues that are not just scientific issues, but profoundly humanistic issues. And in the end, I want to invite humanists to get into the water, to play with the scientists, and help us to address this issue in a meaningful way. Now, the conventional history of thinking about climate change begins with the French mathematician and physicist Joseph Fourier, who was the first to discover that the atmosphere traps heat. Fortunately, I don't need those papers, so that's how it is with most papers when all is said and done. The English scientist John Tyndall identified which gases in the atmosphere actually function to trap heat. That was in 1861. Svante Arrhenius, who won the Nobel Prize for Chemistry, Swedish Nobel Prize winner in 1903, sort of as a hobby was interested in the heat-trapping properties of the atmosphere. And in the 1890s, doing essentially back-of-the-envelope calculations, he calculated that a doubling of atmospheric carbon dioxide would produce a 1.5 to 4.5 degree centigrade warming of Earth's mean surface temperature. Now, interestingly, this number is very close to the range that has been calculated by using contemporary supercomputers. So there's a sense in which we already knew, or at least had a well-supported guess at what the impact of a carbon dioxide doubling would be on temperature on Earth's surface. Guy Callendar was a very interesting character. He was a British engineer. He worked for the British National Coal Board, and there was essentially a spike up in temperatures in the 1920s and 30s. And Callendar claimed that, in fact, anthropogenic, that is, human-caused global warming, was already underway. Now, Callendar thought this was quite a good thing, as did Arrhenius. So when people were talking about the possibility of global warming during this period, they thought it was terrific because it was going to keep the dread glaciers at bay. Essentially, all of human life and culture as we know it has developed within an interglacial period. And the idea of the next glaciation is one which many people, including myself, having grown up in Southern California, view with some trepidation. Callendar's research was essentially kept alive by a Canadian scientist, Gilbert Plass, who worked for General Motors, which is kind of another interesting irony. And essentially, Plass argued that if we continued on our present course, average global temperature will increase at the rate of about a little over 1 degree centigrade per century. He published these results in a series of papers in 1956. Now, none of this work was obscure. As I've already said, one of the leading contributors to the development of this science won the Nobel Prize in Chemistry. Gilbert Plass, in 1959, published his views in that obscure esoteric magazine, Scientific American, an article called Climate and Carbon Dioxide. So there was no mystery, really, about the development of this science. 1957 was a very important year in the development of the geosciences. It was the International Geophysical Year, and many of the baseline measurements that we have about the Earth system were originated in that year. It was a year in which there was a great deal of research that was done, and what people discovered is that, in fact, there was simply a lot of data that we didn't know, we didn't have, so we weren't really able to detect whether there were changes. So in 1957, we began to do a lot of instrumentation. including the establishment of the first observatory for measuring atmospheric carbon dioxide in Hawaii, and essentially the record that documents the increase of carbon dioxide in the atmosphere comes from measurements that are made in Hawaii beginning in 1957. These measurements were first made by a man named Keeling, Charles Keeling, but Roger Revelle was in many ways the prime mover behind this. Roger Revelle was for many years a professor at Harvard, where one of his less successful and more indifferent students later became Vice President of the United States, Al Gore. And then Revelle moved out to San Diego to the Scripps Institute of Oceanography, where he began doing this kind of work. And he wrote in a paper in 1957 that human beings are now carrying out a large-scale geophysical experiment of a kind that could not have happened in the past, nor be repeated in the future. Within a few centuries, we are returning to the atmosphere and oceans the concentrated organic carbon stored in sedimentary rocks over hundreds of millions of years. Now, one thing that's interesting about this article is it's written in this very neutral tone. This is simply an experiment that we're doing with the planet. Isn't that cool? Well, he doesn't actually say, isn't that cool? But he doesn't express any particular fear or trepidation about this experiment. Although in conversation and in some of his private correspondence, in fact, he did express some concern. But the issue, which had been a subject of scientific investigation, sometimes thought good, sometimes thought indifferent, perhaps watched with a certain amount of fear, really began to enter in a small way public policy discussions in the 1960s. So in 1965, President Johnson's Science Advisory Committee Board on Environmental Pollution wrote in a report to President Johnson, by the year 2000, there will be about 25% more CO2 in our atmosphere than at present. And this will modify the heat balance of the atmosphere to such an extent that marked changes in climate, not controllable through local or even national efforts, could occur. So already in 1965, in the Johnson administration, the warning was beginning to be sent. In 1979, the American National Academy of Sciences, our most credible and prestigious source of scientific information, published a report in which they said, a wait-and-see policy may mean waiting until it is too late to avoid significant climate changes. Well, guess what kind of policy we have pursued. In 1987, the United Nations General Assembly commissioned a report that was written by a commission chaired by the Norwegian Prime Minister, Gro Brundtland. And this report was commissioned in 1983 and published in 1987 under the title Our Common Future. This arguably was one of the most influential documents of the 1980s. It was translated into more than 24 languages, was widely read all over the world. And in that report, published in English by Oxford University Press, the Brundtland Commission places climate change in the larger frame of the interlinking crises of North-South division and environment and development. And it was that report that popularized the phrase sustainable development. Now, 1988 was a very important year for climate change. In 1988, there was a very significant national drought that gripped the United States, particularly the American Midwest, that severely impacted agricultural production. And on June 23rd, Senator Al Gore had a hearing of his Senate committee. And Jim Hansen, a climatologist at Columbia University in NOAA, testified that he was 99% certain that global warming had begun. And that testimony was on the front page of the New York Times, and as journalists like to say, above the fold. So this was an extremely influential moment in the development of this issue. Senator Tim Wirth of Colorado during the same year introduced a bill. This is almost unimaginable given the politics of the last 10 years, but he introduced a bill with 15 co-sponsors, including Republicans as well as Democrats, calling for a 20% reduction in greenhouse gas emissions from 1990 levels by the year 2000. Now, also in that year, the IPCC, which is an acronym for the Intergovernmental Panel on Climate Change, was established. And I have to take a couple of minutes to say something about the IPCC, which is perhaps the single most important player in assessing scientific knowledge about climate. The IPCC was commissioned by the United Nations Environment Program and the World Meteorological Organization not to produce new information with respect to climate change, but essentially to bring together what was known and to assess the literature, to synthesize the literature, and to write summaries for policymakers. So it's a very, very interesting process involving scientists from all over the world whose mission was to really try to establish a common scientific basis on which we as a community of nations could make science, could make policy with respect to climate. Now, there's an interesting little backstory about how the IPCC was first established. As most of you are probably aware, the United States has not been very friendly towards the IPCC in recent years. In fact, the previous chair of the IPCC, not the current one, was essentially dumped from his position because of objections from the United States government. And in general, as you know, the United States doesn't very much like these sort of, kumbaya-type international organizations and international groupings of people that make reports and issue recommendations. But in fact, the single largest mover behind the creation of the IPCC in terms of national governments was actually the Reagan administration. And the reason the Reagan administration wanted to establish the IPCC is because they wanted to make sure that the Wirth bill did not pass. They were afraid that, in fact, we might actually have a national climate change policy. So the fallback position, Plan B, if you will, was to say, well, we're not really sure whether the science is firm enough. Let's organize an international scientific assessment, and then we'll see whether we have a basis for making policy. So ironically, the United States, which is often at odds with the IPCC, was in fact the prime mover in the establishment of the IPCC. Now, the first IPCC report was published in 1990, and one of the things we're going to see is that really the whole tenor of the climate change debate in the United States has changed after the publication of the fourth report in 2007. It's as if the IPCC, had finally found the smoking gun, that it had gone up to the mountain, it had found the tablets, it had brought them back, climate change is real, we now have to act. But in fact, if you read the IPCC reports, what you get is what you get in normal science. You get the slow accretion of scientific information. But the basic case has not really changed appreciably in almost 20 years. So in 1990, the IPCC writes, we are certain of the following. There is a natural greenhouse effect. Emissions resulting from human activities are substantially increasing the atmospheric concentrations of greenhouse gases. These increases will enhance the greenhouse effect, resulting on average in an additional warming of the Earth's surface. In 1992, the Rio Earth Summit occurred, which was the largest gathering of heads of state in the history of the world, and the Framework Convention on Climate Change was signed and later ratified by virtually every country in the world, including the United States. And Article 2 states the objective, and I'm going to come back to this later in the talk, but it's a very interesting statement and very important. The ultimate objective of this convention is to achieve stabilization of greenhouse gas concentrations in the atmosphere at a level that would prevent dangerous anthropogenic interference with the climate system. The United States, along with every other country, is committed to this objective. And the responsibilities for fulfilling it are to be common and differentiated. And we'll say more about what that means later. In 1995, the IPCC produced its second report in which they stated that the balance of evidence suggests a discernible human influence on global climate. In 2001, they produced the third report. Meanwhile, there's been some policy action that has taken place in the meantime that I'll return to if I have time. But in 2001, the IPCC produced its third report, which essentially says that the global average surface temperature has increased over the 20th century by about 0.6 of a degree centigrade. There's new and stronger evidence that most of the warming observed over the last 50 years is attributable to human activities, and human influences will continue to change atmospheric composition throughout the 21st century. In 2007, we get the sort of IPCC report that is often considered to be the smoking gun, particularly that last phrase, that anthropogenic warming of the climate system is unequivocal. But yet you can see when these conclusions are brought together in this way that we really just have growing confidence in the conclusions, growing development of the warming, and nothing that's really so dramatically different about the 2007 report. These are more details from that report that I think I will skip over very quickly in the interest of time. Now, let's talk a little about what's going on with climate change. It's an issue which, in terms of its basic concepts, is very simple. In terms of the details, is very complex. And there are a great many uncertainties, particularly with respect to regional impacts of climate change. But the basic idea is that essentially energy comes in through the atmosphere. Much of it is reflected back from the Earth's surface. Some of it is absorbed by the Earth's surface, and some of it is trapped before it can escape into space. So this is essentially the model of how the greenhouse works, comparing it to the human construction of a greenhouse. Now, the idea that there is such a thing as the greenhouse effect, independent of whether humans are contributing to it, is perhaps the single best established conclusion in planetary physics. What we know, for example, is that if you just calculated the temperature of the planet Venus based on its distance from the sun, its mean surface temperature would be about 54 degrees centigrade. But in fact, its actual temperature is a horrifying 474 degrees centigrade, and that's because it essentially has a runaway greenhouse effect. It has a very dense atmosphere that traps much of the solar radiation that strikes the surface of the planet. Mars, on the other hand, its predicted temperature based on its distance from the sun is minus 53 degrees centigrade, and guess what? That's what you get because Mars has lost its atmosphere. So there's no atmosphere trapping any of this solar radiation on the surface. And of course, in the case of Earth, the predicted temperature would be a rather chilly 0 degrees centigrade on Earth's surface, were it not for the fact that we have an atmosphere that traps heat that would otherwise radiate into space. And therefore, what we know is that Earth is just right, with a mean surface temperature of about 16 degrees centigrade. And I'll let you explain this either in terms of physics or God, whichever you find more appealing. Now, this is actually this is probably the most data-rich slide that I'm going to be showing. And the point of it is actually relatively simple. What you have at the top is you have levels of atmospheric carbon dioxide, and what you have on the bottom are temperature variations. And this shows you the paleoclimate up to the present. And what you see just at this level of aggregation is that there are correlations between how much carbon dioxide there is in the atmosphere and what the surface temperature of the Earth is. Now, correlation isn't causation. It could be the case, of course, that the temperature warming produces increases in CO2, or it could go the other way. In fact, there is science about that that we could go into in the question period if you want. But at least at this point, what I want you to see is that it's not crazy to think that there's an association between changing the concentration of greenhouse gases in the atmosphere and affecting Earth's temperature. Now, where does that come from? Where, if you go back to the previous slide, what we see is increasing concentrations of carbon dioxide in the atmosphere. That's what we have in the upper right-hand corner. Well, where does that come from? Well, no surprise, it comes from increasing carbon dioxide emissions. Essentially, industrialization has been built on smokestacks, and smokestacks emit carbon dioxide. Now, one thing that you'll see from this slide that might initially give you some cause for comfort, but in fact should have exactly the opposite effect, is that emissions are going up much more dramatically or much more quickly than the concentration of carbon dioxide in the atmosphere. Well, guess what? The problem with greenhouse gases is that they hang around the atmosphere. The concentrations build slowly and continue to persist for very, very long periods of time. This particular chart is actually out of date. People used to think that carbon dioxide's residency time in the atmosphere was about 100 years. Now what people say is that the residency time is variable, but that much carbon dioxide is in the atmosphere virtually forever, and much of it hangs around for 400 or 500 years. Now, what that means is that when you drive your car to the Minute Mart to get a Slurpee, each molecule of carbon dioxide doesn't just quickly cycle through the atmosphere, but it goes into the atmosphere where it's going to stay for centuries, affecting the climate of future people. Think about that the next time you want to drive to get a Slurpee. The analogy I like to use with this is it's a little bit as if you're standing on someone's foot and it hurts. And you go, oh, it hurts. So you get off their foot and the pain stops. But in the case of increasing concentrations of greenhouse gases in the atmosphere, it's as if the pain doesn't stop. You stop emitting, but all the carbon you have emitted remains for a very, very long time. Now, I've given you a very coherent, very narrative account of the history, very brief overview of the history of climate change science and its development. But, of course, one can always point out all kinds of assumptions, all kinds of value commitments that the science presupposes. For any science, there is a way of telling the story where it seems much more contingent than the way that it appears normally in science textbooks. And indeed, there is an entire field of academic endeavor, normally called science studies, which makes its living doing just such a thing. So, for example, consider model validation. One of the things that's confusing about climate science is that it doesn't conform very closely to the model of science that most of us learned in the first chapter of our science textbooks. That rather than going out and making observations and making inductive generalizations about the world, climate scientists essentially build huge, very, very complex models that can only be run on the world's fastest supercomputers. And what they seek to do is to simulate past climates. And they try to build models that will, in fact, conform to what we know about the present model system. And then they will run experiments and see what happens if you force additional amounts of greenhouse gases, for example, into the atmosphere, what happens, what is the glimpse that this gives us for the future? And of course, the glimpses, the scenarios that are the most robust, that are the least sensitive to inputs, are the ones about which we have the most confidence. So this is a science that relies on simulation and robust results, rather than a science that conforms to anything like the deductive or inductive models that most of us were taught. And since, especially in the early days, there wasn't always that much climate data for the models to be based on, and since there are still many things about the climate system we don't understand in terms of causal relations, all of this continues to be filled in. And this raises issues about what are sometimes called flux correction, essentially fairly ad hoc corrections of variables in the models in order to get them to better simulate climate. There are changes in what are called the parameters of models to do the same thing, and so on. And quite a bit has been written about this in philosophy of science and in science studies. There are also ways of, when we talk about the historical record and we produce the kinds of graphs and charts that I've shown you earlier, I think it's always important to remember that a lot of assumptions go into producing those graphs and charts. This is a figure from an old paper of mine, and essentially what this virtually unintelligible scatter plot is a scatter plot of are particular observations of temperature. Particular temperature observations are just simply plotted in this field. Okay? If you just took the data points that we had, put them on a scatter plot for this period, that's what you'd get. But guess what happens when we do some statistics on it? We get something that looks like this, we get trends, and we get lines. Now, there's nothing wrong with that. It's not that this is a distortion of the data. It's just one way of drawing a curve through these data points. And of course, there are other ways of drawing those curves, and it's important to remember that. Similarly, here's a chart which shows you global mean surface temperature from about, 1860 to present, and you can see this upward trend. Now, whether or not you think this looks like climate change or climate variability, at least according to some people, is going to depend on whether you put this embedded in the larger paleoclimatic record. So essentially, the previous chart that I showed you is all embedded in essentially a millimeter on the right side of this chart. This gives you the much longer time series of climate on Earth. So maybe what we're seeing is just a passing blip on that, according to that scale. So these are all important observations to make and important things to interrogate about science. Science is value-laden, and the knowledge that it gives us is probabilistic. But science is also objective and responsive to the world. We should all be scientific fallibilists. That is, we all should be willing to revise our scientific views. But here I think is the really important point. Climate change science is as well confirmed as any complex science that bears directly on public policy in which there are very important interests at stake. If it doesn't seem that way, to a great extent it doesn't seem that way, because there has been an industry of denying climate science in much the same way previously that there was an industry of denying the science that led to smoking bans and controls on smoking. And indeed, some of the same individuals were involved both in funding the deniers of the science in both cases, as well as in denying the science in both cases. Okay, so now in the time that remains to me, I want to turn really to the moral and political problems of climate change. So the problem that we face is at the end of the day has a very simple structure in terms of the policy question. People emit greenhouse gases. These gases accumulate in the atmosphere. These accumulations trap heat and produce global warming. Global warming produces climate change. Climate change will transform the physical and human geography of the planet affecting where and how we live our lives. In other words, we're going to be seeing a lot more things that look like this. This is a picture from Hurricane Katrina. My claim is not that Hurricane Katrina was caused by climate change, but rather we will see many more extreme events of various kinds as a result of climate change, and they will also be more intense. And we're already living in a world in which the poor suffer most from these extreme events. 96% of disaster-related deaths in recent years have occurred in developing countries. Of course, we read about disaster-related deaths in the rich parts of the world that produce and buy newspapers, but most of them actually happen in poor communities and poor countries. Bangladesh is a country I choose almost at random as one that will be extremely hard hit as a result of climate change. So Atik Rahman writes, we expect the severity of extreme events to increase. Their frequency will also increase. At least 20% of the country will be inundated with salt water. So our food system will collapse, he says matter-of-factly. Some 20 million people will be displaced over time. When the next cyclone comes, it will penetrate further, and it will kill more people. The refugees have started. People are moving already. The tides are getting higher. All this translates into catastrophe. And it's observations like this that increasingly have led people in developing countries to say things like this quotation from President Museveni of Uganda, that climate change is an act of aggression by the rich against the poor. Now, we've seen already in passing that the poor will suffer most from climate change, but why an act of aggression? Well, this slide, which essentially shows you greenhouse gas emissions by country in 2000, which includes emissions from land use changes, and essentially the redder, the hotter the color, the more the emissions by country. And what you'll see is, of course, all the usual suspects in the United States and Europe, North America and Europe, are doing the emitting, with the addition of Brazil and China and India here, and Indonesia turn out to be pretty large. But of course, Africa, very little emissions, much of South America, very little emissions. Now, this is by country. Now, what happens if you look at the data per capita? Sorry, this is by country. Oh, no, this is per capita greenhouse emissions by country. If you look at the data on a per capita basis, how much does an individual emit? Well, guess what? India and China and Brazil drop out because the average American emits 3 or 4 times as much as the average person in China. It's just that there are many more of them. So on a per capita basis, then the map begins to look even more familiar. And we can, of course, control for land use changes, and we get very much the same map. But here's the one that I think is the most revealing. If we take into account responsibility for current CO2 in the atmosphere, which includes historical emissions, then the map is just about perfect in the sense of it's the rich countries that have done the emitting, and it's the poor countries who have done very little of the emitting. The World Health Organization has claimed that already we're seeing an increase in mortality as a result of climate change. And again, you see essentially the converse of the previous map that I showed you. The emitting is going on in the countries of the north, and the dying is going on in the countries of the south. And it's this kind of data that lead people like President Museveni and various climate campaigners to say that essentially a great global injustice is being committed by the countries of the north against the countries of the south. And while I agree with that, it is important to recognize that we're going to have to change our conceptions to some extent of what a global injustice consists in order to account for problems such as climate change. Because climate change fails to display some of the central characteristics of a global injustice, of the sort that an aggressive war does, for example. The harms caused by climate change are not intentional. People are just going to the store to buy their Slurpees. They're not meaning to kill people in Bangladesh. Indeed, some nations, like the United States over the last 8 years, that cause harms have claimed ignorance. They claim that, in fact, we don't know enough to say that these harms are being caused. Well, other nations, European nations, for example, that continue to cause these harms also compensate those who suffer. But I think the most important difference is that it is individual people who cause climate change and suffer the consequences, and they are distributed through all the countries of the world. So here's a graph that I take from my colleague Steve Pacala at Princeton. And essentially, the richest 500 million people in the world whose incomes are $30,000 a year or more emit half of the world's fossil carbon. Now, lots and lots of Americans and Europeans are over that $30,000 threshold, but not all of them are. And an increasing number of Chinese people are over that $30,000 threshold. And indeed, in every country in the world, no matter how poor, you will find some people who are over that threshold, who are responsible for half the global carbon emission. So this might lead us then to think that a better way of thinking about climate change than as an issue of global justice is to think of it in terms of individual moral responsibility. And indeed, just as I think climate change does pose questions of global justice, though we need to revise those concepts, so also I think it poses questions of individual moral responsibility. But I also think it's going to have to lead us to revise those concepts as well. Our paradigm of a case of individual moral responsibility is the sort of simple one in which Jack intentionally steals Jill's bicycle. Okay? No question about that. We have a single agent causing a harm to another person intentionally and so on. But when we begin to complicate this a little, imagine that Jack is part of an unacquainted group of strangers, each of which, acting independently, takes one part of Jill's bike, resulting in the bike's disappearance. Yeah, this still seems like Jack is morally responsible here, but our clear intuitions begin to get a little fogged up. And the more that we begin to change the example, Jack takes one part from each of a large number of bikes, one of which belongs to Jill, the intuitions get increasingly foggy. We now separate Jack and Jill through space, and we separate them in time. And then finally we come to the case, which I don't want to say is exactly like climate change, but it's more like climate change than the case with which we began. Acting independently, Jack and a large number of unacquainted people set in motion a chain of events that causes a large number of future people who will live in another part of the world from ever having bikes, okay? So what I want to say is, yes, Jack, us, we are morally responsible for these actions, but it is going to require some revision of our everyday moral conceptions in order to encompass this kind of responsibility in this highly globalized world. Now let's go back to the policy problem that we actually face, and we'll finish up by talking about that problem, because whatever is true about our concepts of global justice and of individual moral responsibility, we face a problem. We face a problem to which we are legally committed by being signatories to the Framework Convention on Climate Change to actually solving. Now, what will it take to solve that problem? Well, the first thing is, what exactly counts as dangerous climate change? Now, President Bush in 2007, when he decided he was interested in the issue, decided climate change was real, he coupled that statement by saying, well, it's just subjective, this idea of dangerous climate change. Every nation has to decide for itself what counts as dangerous. Now, that's a mistake. It is an evaluative question. It isn't a merely, purely scientific question, what counts as dangerous, right? It has to be informed by our values. But we can come to conclusions about this, and indeed, beginning in the European Union and globally, we are moving to the conclusion that dangerous anthropogenic interference, that the threshold for that can roughly be calibrated at a 2 degree centigrade warming of the Earth's mean surface temperature. Why 2 degrees? Because up to 2 degrees, there'll be winners and losers. There'll be losses that can be adapted to, at least by people with resources. Beyond 2 degrees, we start turning into all losers with very few winners, except maybe comparative winners, and we also start running increasing risks of abrupt climate change, that is, catastrophic climate change. But what do we have to do to stay under that 2 degree threshold? Well, We've already experienced an 0.8 of a degree warming. We're probably committed to an additional 0.8 of a degree from the gases that are already in the atmosphere. So in order to stay below 2 degrees, global emissions will have to peak in the next 10 to 15 years, then rapidly decline to well below 50% of 1990 emissions by 2050. That looks pretty tough, but for those of us in this room, it's even harder than that. Because some developing countries will need to increase their emissions in order to develop. Now, when I say, for example, Africa, I don't mean that I don't know that Africa is not a country. Africa is a continent with many countries, and most of those countries will need to increase their emissions. Now, other countries with low per capita emissions, such as India and China, will take longer to stabilize, just given their trajectory of development. So what that means is that for North America, Europe, and Australasia and Japan, they're going to stay under this 2 degrees centigrade, in which each part of the world does its part. We're going to have to reduce our emissions by about 80% from 1990 baseline by 2050. The window for taking action is small and is closing rapidly, especially when you think about the time horizon that's required to develop technology, to diffuse it, to replace and turn over infrastructure. And one thing you immediately see is that many of the technologies that are popularly discussed as solutions are not likely to help with the immediate problem that we face, although they may have a role to play in the future. It simply takes too long to build nuclear plants. Hydrogen cars are too far off in the future, even if you can figure out what the primary energy source for hydrogen is. And similarly with carbon capture and storage in coal-powered plants. What, in fact, are we doing? Are we moving closer to dealing with the problem? Well, unfortunately, not. Atmospheric concentrations of carbon dioxide are continuing to increase about 2 parts per million per year, and even the emissions are beginning to increase. One result of the current global economic collapse that we are beginning to live through is that it probably will reduce carbon emissions. But one doesn't take much pleasure in that approach to emissions reduction. So the warming that we're committed to is in fact increasing all of the time. And of course the underlying trends that drive increases in greenhouse gas emissions are also increasing. Population growth, increasing energy use, and increasing meat consumption. The reason I mentioned meat consumption is because raising animals for food essentially concentrates vast amounts of energy in producing that meat, and the animals themselves produce methane gas, which is a much more active greenhouse gas than carbon dioxide. Now, everyone these days, since 2007 and the Nobel Peace Prizes, admits we have a problem and we have to do something. So we're now in the era of economics, and if I had more time, I would tell you why economics is not going to solve our problems and economic models are not going to tell us what to do. And the reason, essentially, is because they are too infused with values. That it's fundamentally the value questions that drive the economic models. And that's why we need humanists. Both science, as I've mentioned, and economics, as I quickly skipped over, essentially rest on a pyramid of values. There are values all the way down that need to be analyzed, that need to be reflected on, that need to be thought about. But secondly, as I've suggested, we need new conceptions of justice and of moral responsibility that fit the globalized world in which we're now living. We essentially have 17th century rural notions of political justice and moral responsibility. They need to be revised, and it's the job of humanists to develop those conceptions. Thirdly, we need to answer the Peggy Lee question. Is this all there is? The first George Bush famously said in Rio in 1992, "The American way of life is not up for negotiation." It is up for negotiation. If we are to avoid climate catastrophe, the American way of life is going to have to change. And we're going to have to decide whether there is more to life than consumption. That question, what does the meaning of life consist in? What is the nature of the good life? Is a question as old as the Greeks. And finally, what makes people act? People don't act in response to the kinds of charts and graphs that I've shown you today. They act in response to stories, to pictures, to plays, to narratives, to songs, and to poems. And what we need to get people to respond to climate change, to get us to respond to climate change, what we're waiting for is the Uncle Tom's Cabin of climate change that is yet to be written. So the main challenge here is, to go back to the theme, coping with change. Humans are an extremely adaptable species. We've lived in colder worlds, we could live in warmer worlds. The challenge we face is to adapt to a very, very rapid change that is now underway. That will require us to intentionally change and not simply be the objects of change. What will it take? I think it will take a global movement that sees climate change essentially as a new kind of moral problem, which is just as urgent to act on as the problems of racism, sexism, and global poverty. And what is required? Well, an activist minority, a permissive majority that lets the activist minority work, and political leadership. And it may now be true that we have, finally, political leadership. We'll see in the next few months. And if so, then the rest will be up to us. Thank you very much.